Hello everyone, we are Jiahao Ye, Ziheng Chen, and Shikun Sun. Today we will present our icds final project, Chatbox. It is an enhanced distributed chat system. Based on the original socket and chat project, we added a graphical user interface, AI assistant features, online games, and several useful tools. The goal of this project is to remake the project more user-friendly and interactive. Our system integrates a modern graphical user interface, GUI, AI-powered assistance, and social interactive gaming into a unified ecosystem. This slide summarizes our main functions. We divided them into 4 groups. The first is core communication, including login, real-time chat, online user display, file transfer, and emoji. The second is AI-powered features, including chatbot, memory, personality, assignment, group chatbot, AI picture generation, summary, keywords, and send time analysis. The third is online gaming, including Snake leaderboard and multiplayer tic-tac-toe. The last group is tools. Many original terminal commands are now available as GUI buttons, so users do not need to remember command syntax. There are time, poem, search history, and clear chat. Now I will move on to the demo part to demonstrate GUI functions, then chatbot, online games, bonus AI topics, and PyModel usage. First, I start the server by running chatserver.py. Then I open 2 clients with chat-cmdl client.py. Each client first shows a login window. After entering a valid username, the main GUI appears. The interface has 2 main areas. On the left, there is a sidebar with profile information and function buttons. On the right, there is the chat display area, input box, emoji button, file button, and send button. This satisfies the basic GUI requirements. Users can type messages, send them, receive messages in real time, and clearly see both sent and received messages. We also added a clear chat function. When I click clear chat, the current display area is cleaned, but the client does not need to restart. When logged in, the GUI will show main functions. Next, I will show login and search history. The login function prevents duplicate usernames. When a user enters a name, the client sends a login request to the server. If the name is already used, the server rejects it. Otherwise, the user enters the chat system. For search history, I can click the search button and enter a keyword. The client sends the keyword to the server, and the server searches the indexed chat history for its user. Then the matched messages are shown in the GUI. This keeps one useful feature from the original command line system, but makes it easier to use. This slide shows emoji and file transfer. For emoji, I click the emoji button and insert an emoji into the inbox. Then I send it like a normal message. For file transfer, I click the file button, choose a local file, and send it to the connected user. The client encodes the file with base 64 and sends it through the socket protocol. On the receiver side, a save dialog appears, and the user can save the file locally. These features make the chat system closer to a real messaging application. Now I'll show some tool buttons. The Who button displays online users and current chat groups. The Time button asks the server for current system time. The Poem button allows the user to request a sonnet by number. These were originally text commands, but now they are integrated into the GUI. This makes the system easier to demonstrate and easier for users to operate. Next is the chatbot function. I click the bot button to enter chatbot mode. Now I can ask a question. For example, explain basic GitHub function. The chatbot is implemented in chatbot client.py. It can use a local Olema model, and the code also supports an OpenAI compatible chatbot class. The bot also keeps recent conversation history, so it has memory. This means the answer can depend on previous messages instead of treating every message as isolated. We also implemented two chatbot bonus functions. The first one is personality assignment. I can click bot style and enter a personality such as a friend Python learning assistant. After that, the chatbot changes its response style based on the new system prompt. The second one is group chatbot. We have a separate bot client that can log in as AI bot. When it is invited into a group chat, it watches recent group messages and responds when users mention it with @bot. This makes the chatbot more integrated with the chat system, not just a separate private assistant. Now I will demonstrate the online game features. The first is Snake. I click Play Snake and a separate Snake game window opens. The player controls the snake with arrow keys. When the game ends, the final score is automatically submitted to the server. The server records the best score for each player and sorts the leaderboard. When I click leaderboard, the client requests the ranking from the server and displays it in the chat window. The second game is Tic-Tac-Toe. Two users enter the same room number. The server matches them into one game. When a player clicks a square, the move is sent to the server. The server checks whose turn it is, validates the move, updates the board, checks for a winner to draw, and sends the updated state to both clients. This shows that our chat system is not only for text messages, it can also support simple multiplayer interaction. This slide shows several bonus AI features. First, AI picture generation. The user can click AI picture or type AI pic prompt. The system sends the prompt to an image generation API, saves the generated image locally, and displays it in the chat window. Second, chat summary. The GUI stores recent chat messages. When I click summary, the program sends recent chat history to the AI model and returns a short summary. Third, keyword extraction. When I click keywords, the system extracts the main topics from recent messages. These features are based on actual chat history, so the result changes depending on the conversation. This slide shows send time analysis. When users send or receive normal chat messages, the system can analyze the emotional tone of the message. It classifies the message as positive, neutral, or negative, and displays the result in the GUI. This is a small feature, but it makes the chat system more intelligent because it analyzes the meaning and emotion behind messages. During development, we used PyMono as an AI-assisted development tool. We used it to generate code ideas, debug models, and improve the user interface. For example, PyMono helped us inspect the GUI message flow and understand why repeated message display could happen. For example, I asked PyMono to explain how to integrate a local lemma model. PyMono was useful not only for writing code, but also for debugging and organizing the project structure. Now I will discuss the technical implementation. The main libraries we used include tkinter, socket, base64, Ollama, and OpenAI compatible APIs. Compared with the original system, we made three important improvements. First, we improved visibility. The online user list is now formatted clearly instead of showing raw or confusing output. Second, we debugged the repeated display problem mentioned in the guideline. We separated normal chat messages, system messages, and feature commands more carefully. Third, we improved the workflow. Users can use most tools while chatting, such as Time, Who, Search, Poem, File Transfer, AI tools, and games. They do not need to leave the current chat first. For reflection, I think this project helped us understand how a distributed application can grow from a simple command line program into a more complete system. One challenge was combining socket communication with tkinter. Socket receiving many block the program, but the GUI needs to stay responsive. We solved this with background threads. Another challenge was integrating many features without making message handling messy. We used JSON messages and command prefixes to separate normal chat, files, games, and AI commands. In conclusion, our project turns a terminal-based socket that system into a GUI chat application with real-time communication, AI features, games, and useful tools. Thank you for watching.